All right, pre-cal, we are going to talk about asymptotes now, because if you will recall, asymptotes occur in rational functions. If you'll think about your reciprocal parent function, which is f of x equals 1 over x, remember what the graph looks like, okay? Well, it looks better than that. Okay, so we have a restricted value because x can't be 0. That means we have a vertical asymptote, and that's essentially what asymptotes are. They're values that occur because of restricted values, etc., etc., and they can only occur when we have a rational function, which means our division of two polynomials. So if we look at this example right here, let's say I've got x squared plus x minus 8 over x plus 3. Okay, x cannot be negative 3 because then we would be dividing by 0. So our domain restrictions actually need to be written like this. All of x such that x cannot be equal to negative 3, and then this little symbol here just means that x is a set of real numbers, all right? So that is what I'm going to, or that's how I'm going to write my domain. Okay, so let's talk about vertical asymptotes. What are my vertical asymptotes? Well, my vertical asymptotes, oh my, they are essentially vertical lines occurring why can't I write? At the restricted x values that the graph essentially jumps over, okay? So a graph is not going to cross a vertical asymptote because those values, x can't be those values. So vertical asymptotes are going to occur at these restricted values. So your vertical asymptote comes from your denominator. So I'm always going to abbreviate these as VA just to make things easier for us. So how are we going to find them? We are going to find vertical asymptotes by factoring the denominator. My handwriting is terrible. Sorry, kids. If we can. If we can't, then that's okay. And then setting those factors equal to 0 and solving, okay? Just like I did right there. Okay, I set that equal to 0, or I essentially solved it, and that's how I discover my vertical asymptotes. All right, so now let's talk about horizontal asymptotes. What are they going to look like? How do we find those? Well, a horizontal asymptote, I'm going to abbreviate that as HA. What are these? Of course, these are going to be horizontal lines. The graph can jump over or cross. Okay, so a horizontal asymptote, its origin does not come from a restriction in the domain. Therefore, your graph can cross a horizontal asymptote. So there are rules here under the how. Okay, so if your numerator degree, so we are going to revisit the degree of a polynomial here. If the numerator degree is less than the denominator degree, you have a horizontal asymptote at y equals 0, which is essentially the x-axis. So the x-axis would act as the horizontal asymptote. If the numerator degree is equal to the denominator degree, then you're going to have a horizontal asymptote at y equals a ratio of leading coefficients. This will make sense when we do problems. If your numerator degree is greater than your denominator degree, then you do not have a horizontal asymptote. There's no such animal. So that is essentially how we do vertical and horizontal asymptotes. In the next video, we're going to actually do some examples so these make more sense.